Hey everyone, welcome back. This is part 11 of the processing tutorial. In the last lesson, what we got working was this program here that can draw an arbitrary number of balls to the screen. We did that using these 4 floating point arrays and this integer variable, which we can kind of adjust in order to change the number of the balls. We also talked about this new operator, which what it does was it creates a certain amount of space in memory for us to put some type of variable. So in this case, I have 50 balls, and I use number of balls in all of these. And in here, it's creating 50 spaces for floating point numbers. And after that, we took those floating point arrays and all that empty space we created, and what we did was we filled it with random numbers using the random function. And the thing that was really special about random was it's the very first function that we've used that returns a value that we're doing something with. And it's returning a random floating point number between this first number we give it and the last number we give it. And remember, it will never include that last number. Later on, we'll play with random some more and we'll learn how to use it in different ways. But right now, just always assume it's for floating point numbers. Okay, so down here what we did, and this should be familiar to you now, is just use these values that we created in these arrays, and we kind of printed them out and we moved them, and then we check if they hit the walls or not. Alright, so you're probably thinking this code looks pretty good, everything is set up, it's running really well, but to be honest, this the way it looks is not really the way most programs of this type are going to look. This is a very amateurish program. It doesn't use any object-oriented techniques, and the object-oriented techniques are going to make this vastly more simple, and we're going to be able to do a lot more stuff with it when we actually play with them. But for now, I just want you to keep using this code and just get used to using this for now, because even though later we're going to use all these different object-oriented techniques, it doesn't really take away from any of the stuff we've learned here. You're still going to be creating arrays, you're still going to be using for loops, you're still going to be doing all the things we're doing now. You're just going to be doing them more efficiently and in a more effective way. Alright, so what we have, remember, is this. But what we want to do is we want to actually be able to click on these and have them disappear. So how do we do that? Well, to get something to click, we got to obviously use the mouse. So in this tutorial and the next few, I'm going to teach you how to interact more with the program. So instead of using this, because this code looks good, runs right now, I don't want to play around in here. What I'm going to do is use this project right here, and we're going to play around in this project with the mouse. So the best place to look whenever you want to learn something new about processing is obviously just go to the references. And in the references, you're going to see all this information about mouse and the keyboard and things. And I'm going to talk about the mouse in this one, and I'll show you how most of this works. I'm not going to talk about PMouse XY in any detail. I'll kind of show you when you might want to use it, but I won't tell you really how I would use it in this case. We'll look at most of these functions. Anything with the parentheses here, that's going to be a function. So let's pop back to our program. If you don't have this, just go ahead and get it set up. You just want a window 500 by 500. I've done something odd in here by using the background here. We're going to move it back down to draw in a little bit, but for now, we're going to keep it up here, and you're going to see why. Set the frame rate to 60, and then you're ready to go. So let's go ahead and create our very first function of those. Let's use mouse pressed. And just to test if mouse press is actually working or not, I'm going to make a print line, and I'm going to say pressed. Alright, and then let's run this. Alright, so I've got this window and nothing's in it. But if I click somewhere, you'll see the pressed comes up. And actually, if I click and hold down, it still comes up. I don't even have to let the mouse button up. So how is this working? Well, just like draw is called once for every time the program loop runs, in our case 60 times a second, mouse press is checked. Has somebody pressed the mouse? If they have, go ahead and execute the mouse press function. So that's what it's there for. It's the event loop or the program loop, and it's waiting for us to press a button or move the mouse or do anything that's important. It's still going to draw every time, but it might also do something else. It might call mouse pressed, it might call mouse dragged or moved or key press or something like that. So all these functions are also called in just the same way draw is through the program loop. Okay, so let's do something more meaningful with this one, and let's try to figure out where we've pressed the button at. And you're gonna see some new syntax here, some new technique. I'm using an integer. That's what mouse is. Mouse X is an integer number, and I'm adding it to what looks like a piece of text, or in our case we call a string. A string is anything with the quotation marks around it. That's a string. We haven't learned officially about the string type, and we won't do that until we get to file handling and to printing things to the screen for like text and stuff like that, so we can see our score and other things. But you can take an integer or a floating point or something, and you can do what's called concatenation. And concatenation means you take two different types. In this case, it means take a string type and an integer type and turn it into a string type that I can use. Otherwise, you can concatenate strings and strings to each other as well. So in this case, I'm adding, but it's not really adding. What it's doing is just combining them together. So when I do this and click, we get a nice thing pressed, and then it prints out the number 234. So that's my mouse X right there. It's just a variable, and notice I go to the right and it's going to print these higher numbers, and then over to the left and it prints these lower numbers. Alright, so what we can also do is we can add on our mouse Y. So these two variables are going to detect exactly where we have clicked the mouse. Alright, so looks pretty good so far. We now know that we can use these to detect where the mouse is. Let's actually use them for something more interesting. Let's go ahead and draw an ellipse. So I'm going to say ellipse, and instead of using numbers, I'm going to use mouse X and mouse Y. And then I'm going to do 20 by 20. So what is this doing? Well, it's pretty much doing everything we've been doing so far. It's just going to draw an ellipse, but it's going to draw it with the center at mouse X and mouse Y. So I run this and I get an ellipse, just like this. Alright, looks pretty good. Let's make this a little more colorful though, and we're going to do that using a technique that we learned in last lesson, which was, or rather a function, which was the random function. So instead of a B value or a blue value, I'm going to make a random, and I'll just set it to 255, and then I'll run this. And you'll notice now if I'm clicking, I get these different shades of blue, which is kind of cool. Alright, let's make it a little even more colorful, and let's throw in red as well. So now if I click, I'm going to get a mixture between blue, green, red, no green, blue to purple, pink, things like that. So kind of cool. If you want to go ahead and just put this in for the last one, feel free. That means you're making a completely random color every single time, and you're going to get something like that. Alright, so this looks good. We've got using mouse X, we're using mouse Y, and we're using this mouse pressed. The nice thing is now that you've learned that, you don't have to really change anything if you want to use a different mouse action. So for example, if I want to use mouse clicked now, I can do that, and now mouse clicks works. So mouse clicked is different from mouse pressed because you have to click down and then release the mouse before the action in here is actually done. Alright, let's look at some other ones. This is probably going to be one of the more interesting ones, mouse moved. Visually, we're now going to get this lovely string of ellipses coming across the screen, and I've done something on purpose. I've moved my mouse much faster on each line. So on this first line up here, I moved it very slowly. In the second line, I moved it slowly. This one, I moved it faster. and then faster, and then very fast on the bottom. And you can even get faster where I get something like that. So why is it drawing these ellipses so far apart? Well, that comes down to our frame rate. And our frame rate is 60, which means the draw loop is only called 60 times per second. But if the mouse is moving really fast, it might not be able to update, might not be calling draw fast enough to keep track of exactly where our mouse is. So if you have the frame rate set at 60 or lower, then the frames, if you had it set much lower than 60 actually, these would be drawn farther apart. Because what happens is you draw, then it has to take a little time for the draw loop to come back around and go again, and by that time you've already moved your mouse however far, and then it draws your ellipse again. And the same thing is in here, the draw function gets called or the mouse move gets called. Mouse move can only be called so many times per second. And in our case, it can only be called 60 times per second. If you up this frame rate, these will end up being closer together. Alright, so you can play with that if you like, but it's really not important for this lesson. Now, I'm going to go actually show that one more time because I want to tell you about these other variables. Let's see, run. There we go. So, to detect how far this is moved, if you come back here, you can look at the pmouse x and pmouse y. So these two variables are important for detecting how far these have moved between each program loop. Alright, so just something interesting, something you might want to look at. Alright, we've also got mouse dragged. So mouse dragged is just clicking the mouse down, and we can use this to kind of draw. So if you want to make a drawing program, you'd be able to do it very easily using mouse drag because you have to click and hold and move things around. Alright, so looks pretty good. We actually want to do with our initial program though was not just drag things around and draw really colorful circles. What we wanted to do was be able to click on these balls as they're moving. So in this lesson, we're not going to get to the part where we integrate that into our actual code, but we are going to use the mouse pressed, and we're going to use our draw loop up here, and we're going to actually set up a one circle, and we're going to see how you can click and erase that one circle. Now, to do that, I'm going to have to create that circle. So let's say int x is equal to 100 and int y is equal to 100. And in our draw loop, we're going to want to draw that ellipse at x, y, and 20, 20. So this is nothing we haven't seen before. The next thing I'm going to do is I'm going to put my background back in here, because now that we're using draw, we do want it to erase every single time it's called. You may be wondering why I chose mouse pressed and not mouse clicked. Well, if you think about it, let's say let's come back here, let's draw these balls again. Let's say these balls are moving around, and some of these balls are moving really fast. So if I click on one of them, but by the time I lift my mouse key up, the ball has moved away from me, then it won't register that I actually clicked that ball. So mouse pressed is better because the minute you press the mouse down, it will detect where you are, and it will delete that ball if we actually touched it or not. Okay. Alright, so how do we detect if we have clicked one of the balls or not? Well, to do that, I'm going to jump over here and I'm going to use this diagram of a ball in the wonderful world of Paint. And we're going to use this diagram to illustrate how we might check that out. So each red dot represents a click. The green lines represent the distance from the dots to the center of the circle. Now, if this has a radius, a diameter of 20, it means it has a radius of 10. So how might you detect if the click is inside or outside the ball based on that information? Well, these green lines are all going to be some size. And what can you say for sure about this green line? You can say for sure that it's more than 10. And you can say this green line is more than 10. And you can say for sure that this green line is less than 10. So given that all we really need to know is if the distance from the click to the center of the circle is less than the radius of the circle, then we've clicked the ball. So let me say that again. If we've clicked out here, the distance from where I click, so for example, I click here, let me use that works. So let's say I click here. All right, this distance is more than 10. If I click in here, this distance to this distance here is going to be less than 10. All right, so it's fairly simple. It's just going to use something called the distance formula. I'm going to call it float distance. And if you don't know what it is, you can check out my website and get some supplementary material from there. I'll throw in a link that you can look at about the distance formula. But really all it is it's basic geometry. So I'm going to use square root, and I'm going to say x, which is the center of the circle, minus mouse x. And normally you would say to the power of 2, but it's actually easier when you're coding just to say the same one thing times itself. So x minus mouse x times x minus mouse x plus y minus mouse y times y minus mouse y, and we're pretty much good. So now I'm going to print this out so you can see what it looks like. And we can actually see it working in action. So notice now if I click here, this is the distance from wherever I click to this circle. And if I get right inside the circle, you notice that the distances are all less than 10, just like we predicted. But as I get close to the edge, it starts to get more and more and more. So this works. So our distance formula works perfectly. All we need to do now is use it. So the real question is how do I delete an ellipse? We don't have something that can just delete this line of code. What we actually need to do is one of two things. One, we could set up an if statement where it says, where we turn a switch on and off essentially. Maybe we make a variable something like this, int visible ball, and I set it equal to 1. If the visible ball is equal to 1, then we draw this. I make an if statement here. If visible ball equals 1, draw ellipse. And that would be it. And then down here I can just set if distance is less than 10, then visible ball equals 0 or something. But we're going to do it a slightly different way. Instead, I'm going to say if the distance is less than 10, and actually let's do less than or equal to 10, just in case we click on the edge of the ball. Then I'm going to set these numbers to be drawn off the screen. So I'm going to say x equals negative 100 and y is equal to negative 100. Okay. The reason I'm doing this is because when we transfer it back over to our other code, we would have to make a whole new array keeping track of if the balls are on or off the screen or not. So we'd have to make a visible ball array up here. And I'm just not ready right now to create a whole nother array in the other program. So instead, we'll just change the x and y values to have them being drawn off screen. It is not as efficient as making them visible or not, but it's really not going to hurt the performance of our particular program. All right, so let's run this. Now you notice I'm clicking everywhere around the ball, and the minute I click inside the ball, it is gone. It is drawn somewhere over here, off in the middle of nowhere. All right, so we have successfully implemented a program that uses the mouse to detect where we have clicked our mouse and to detect if it is inside our circle or not. Alright, so looks pretty good. Alright, if you have any questions, leave it here in the comments, or you can also leave it on my website. But next lesson, what we're going to do is we're going to take this code and we're going to use arrays up here to show how we can have mini balls drawn on the screen. Then we'll take this and we'll put it back inside our other code and integrate it so we have balls moving around and we're actually clicking on them to remove them. Alright, so I look forward to seeing you in lesson 12.